Okay, so we're asked to draw a force diagram, identifying the forces in all directions. So first of all, when you read this, you will appreciate that the object is moving on a horizontal surface, okay, so a flat, straight road, okay. So we'll draw the object as like a box, just so it's clear for us, okay. Now it says there's a string attached to the object, and that's what's pulling the object, okay, with this string. And the string is parallel to the horizontal surface. That's kind of important. So the string is attached here, but when it's being pulled, it's sort of parallel. Yeah, it's the same direction as the surface. Now, because the string is pulling the object, the string isn't slack, right? The string is taut, okay? And when the string is taut, okay, because it's not loose or slack, when it's taut, it's got a force in it, and that force we call tension, okay? There's like a tension in the string, okay? That tautness is, and that strength in that string, that tension is what's pulling the object, okay? But it does say there's a resistance to motion of 8 newtons. So we're actually heading in the direction to the right here. So what you should also do is put a double arrow, okay, to show the direction that you're going in, okay, and we put A there for acceleration, so it's accelerating in that direction. But of course, opposing it is this resistance, yeah, okay, the resistance force of 8 newtons, okay. So that's the resistance force there. Now, have we got all the other forces? Have we got all the forces in place? Well, we've got the tension in the string, we've got the resistance force, but it does say identify all the forces, yeah, in all directions. Well, of course, the object itself has got a weight, doesn't it? Yeah. So the weight of this object. Well, remember, to work out the weight, you do mass, which is 4 times gravity times the acceleration, yeah, due to gravity. So 4g is the weight. So we've got a downward force, but remember then, okay, if there wasn't any force opposing this downward weight, the object would just keep falling. But of course, it doesn't keep falling. It stays at sort of that position on the road, okay? It doesn't fall through the road. It's able to stay there. So in order for it to stay there, this force has got to be balanced, and that's balanced by what we call a reaction here. Okay, a normal reaction. Okay, so some people call it N or R, it doesn't matter, okay? So, let's work out B then. It says determine the value of all the forces acting on the object. So let's work out T to start with. Now, because it's moving in this direction, we can apply Newton's second law, okay, in the direction of motion. And remember, the resultant force equals to mass times acceleration, right? Now the resultant force is when you look at the forces in this horizontal direction here. So you've got the T tension in that string, but sort of opposing it is this 8 newtons. Now they're not going to be equal. They won't be equal because this object is actually traveling, yeah? It's going in that direction. So that means the tension in the string must be greater than 8 because it's managing to go this way. So it's sort of overcoming the resistance. So that this T must be greater than 8. But to get the resultant force, you need to appreciate that this 8 is slowing it down. This resistant force is slowing the object down. So the resultant force will be the T pushing it forward, the tension in the string. But you've got to subtract the 8 Newton force, which is resisting it. And that will equal to then the mass, which is, well, mass is 4 kilograms. You just put 4. And an A, what it says acceleration is 0.5. So you've got T minus 8, and 4 times 0.5 is 2. So that means then T will be 10 newtons. So the tension in the string is 10 newtons. Okay, so the other forces we need to find R as well. Okay, now R is easy. And when we sort of resolve vertically, okay, we need to appreciate resolving in the vertical direction. we need to appreciate that the forces are balanced, okay, because there's no movement. So we can say the resultant force is 0. In other words, what's up is equal down, okay, because there's no net gain. It's not travelling upwards or downwards. So in other words, R has got to equal 4G. They're balanced because there's no movement vertically. So R is equal to 4G. Now we know G is 9.8. So if we work that out, we get 39.2 newtons.